Hello and welcome to my talk today. My name is René Freingruber, and today I'm going to tell you something about application whitelisting. So let's have a look at the agenda for this talk. First of all, I will introduce my company, SEC Consult, to you. So don't worry, it's just one slide. After that, we start with the real topic. So what is application whitelisting? Where is that concept used? How can you implement it? And what problems do you face if you try to implement it? I also have here a very interesting, very funny introduction video from McAfee Application Control, which is one software which implements application whitelisting. This is the main product which I will use to demonstrate all my bypass techniques. You will see why I find this video very funny, because there are some very interesting statements inside this video. Then I will introduce McAfee Application Control to you, so I'll show you how you can use that kind of software, which additional features are there, why they are there, and what you can do with these features. Then we come to the real funny part, so how can we bypass application whitelisting? So we'll show you some general techniques which attack the concept of application whitelisting, which work against all kinds of products. So it's also working against app blocker or some other product for application whitelisting. Then we have some product-related findings, like how we can bypass read or write protection or kernel-land vulnerabilities. And at the end, I'll show you some demonstrations so that the stuff is really working. It's not theoretical. We really apply these techniques in our social engineering attacks. And the conclusion is mainly about the response of the vendor. So how did they react to that? What was fixed? What was not fixed? And of course, how you can fix the stuff yourself. We have here one slide about our company. So for everyone who doesn't know us, we are located in Vienna, in Austria. Our headquarters there, but we have offices all around the world. Also in Montreal, we have one office. And I think the most important thing for you is we are also hiring. So if you're searching for a new cool job, just come to us. And with a team of over 60 security experts, so really technical persons, we make over 350 security audits per year. So application whitelisting, I have here a short video. This works.
McAfee Application Control, security through whitelisting. Systems worldwide have been plagued by these threats in the past, all of which were unknown threats until the first time they struck. Application Control is the solution which can give you 100% coverage on day zero and stop these advanced threats. Application Control provides total endpoint security through whitelisting. The whitelist is a powerful tool. It's created by scanning the entire system during install time and cataloging all applications, libraries, drivers, and scripts. When a program tries to run, the system checks the whitelist for its presence and then permits it. However, when a new unknown binary tries to run, it's blocked because it's not on the whitelist. This way, all unknown dangerous threats can be stopped. The whitelist will grow dynamically when systems are updated through trusted channels. Application Control supports 4 different trust channels. Trusted updaters are provisioning/patching tools like SCCM and BigFix. Trusted certificates could be used to self-sign internal trusted apps. Trusted directories can be used to trust remote network file shares or repositories of trusted apps. IT admins could be configured as trusted admins, so all their changes are permitted. These 4 mechanisms make this solution scalable to the largest of enterprises. Memory protection is the second layer of defense complementing whitelisting and makes whitelisted programs exploit-proof. Programs such as Adobe Reader and Internet Explorer can be used safely in spite of having vulnerabilities. A hacker would never be able to exploit those vulnerabilities to circumvent and evade whitelisting.
Okay. We will later see how strong their mitigations are. I think there are some very funny statements in it, like 100% zero-day protections and so on. So to recap, what is application whitelisting? Basically, you set up a system. For example, you have a web server, so you install all applications which you need, like database server, web-based server, and so on. And after that, you install web application whitelisting, which means you create a database of all installed files, so all executables, all libraries, all scripts, and so on. You put this into this whitelist. And after that, if you start an application, it just checks, is this one in the whitelist? If yes, you can execute it. If not, you cannot execute it. So if you go to a website and the website drops a malware, the malware will not be executed because it's not in the whitelist. So this is the main idea behind it. And we often see this kind of application whitelisting in critical infrastructure. So for example, in SCADA environments, I come across this stuff here because we had a project from the Austria government because we are in the next years, we want to use smart meters at every home, and the smart meters connect to the power grid network, and the servers there are protected with application whitelisting. So our job was to test the smart meters and also the application whitelisting and the server. But we often also see that kind of stuff at, for example, high-risk security systems like administrative workstations, or for example, the Technical University in Vienna is also using that kind of stuff for the workstations for the students so that the students cannot start games or something like that. And we have here many different solutions. I have chosen in this case McAfee application control, first of all because of this video, second because it has some other features which are also very interesting to discuss. So I only covered the Windows version because I only received the Windows license. 6.1 was the current version at that time, mainly focused on client operating systems, but it's also working on the server systems the same way. In this case, I have also included Windows XP because in such critical infrastructure systems, you often see Windows XP systems, even if it is not supported anymore. So you should not use Windows XP anymore, but because it is very often used there, I have also included it here in my research. But just don't use Windows XP anymore. If you want to work with this application, you work on the command line, so there's no graphical user interface. And what you're doing is you just call the sadmin program and then give the command which you want to execute. So for example, disable or enable, or you can say solidify, which is the first command. So if you have set up your system, you just say sadmin solidify, then it just iterates over all files on your system and puts them in the whitelist. So in this case, you see here 2,500 files are now in our whitelist. After that, we just have to say sadmin enable, and then we have to reboot the system, and then the protection is enabled. So for example, I've downloaded a debugger in this case and tried to start it, and it just says access is denied. The same is true if I create a script file, in this case test.bat, it just says access is denied, you cannot execute that kind of stuff. And we also have some other kinds of protections like write protection. This is in this case mandatory because they whitelist the path to the executable, so they're not generating a hash, they're whitelisting the path. And then they say you cannot overwrite the whitelisted files. And we also have some kind of read protection. This is only applied to some special files like the password hash file and so on. And we also have memory corruption protections, but I will talk about them a little bit later. Here are some other sites from them. It just basically says the same again. You cannot exploit buffer overflows and so on and so on. Another important concept are updaters, because one of the biggest problems with application whitelisting is how do you deal with updates? So for example, let's say you whitelist the hash of the file, and then, for example, Adobe Reader is updating itself, so it replaces the libraries. So the new libraries are not in the whitelist and cannot be executed. And to deal with this problem, McAfee Application Control uses the concept of updaters. That means these updaters, which are configured by default, can bypass their protection. So they can bypass the write protection. They can overwrite write protected files. And you see here it's mainly McAfee products, but we also have here something from Adobe or the Java update process or Mozilla and so on. But it's mainly McAfee products so that their own stuff is working. I've here drawn a picture. So basically, of the different components, if you're the user, you're just sitting in front of the computer and interacting with the sadmin application, typing there the commands. We also have here a service, which is running with system privileges. So the service, for example, is responsible to generate the whitelist, or the kind of stuff which is more simple to do in the user space. And these two interact with inter-process communication via named pipes. So sadmin is just the front end and just passing the commands with the password to the service. The service implements all the kind of things to do. Then we have a kernel driver which enforces the protections like write protection and the application whitelisting. And they're speaking via inter-process, via IOCTL codes together. Yeah, so the first idea, if we cannot execute our own applications and we want to attack this, what do? We just start to abuse stuff which is already there, which is whitelisted on all systems. So for this, we have three different categories. First of all, we can use something which is there from the Windows operating system. So for example, stuff which is on every Windows Vista system, on every Windows 10 system, and so on. The second category is something which is there by McAfee application control itself. So everything which is installed by them, because if we want to bypass it, we know the kind of applications are there. The third category are some common third-party libraries like Office, .NET Framework, Java, and so on, which is very frequently used. And I basically found applications in all of these three categories which you can abuse. And I think the very, very first thing which comes into your mind if you're a penetration tester is PowerShell, because it's just there since Windows Vista. So if you take a new operating system, it will be just there, and it is whitelisted by default. And PowerShell can be used to invoke shellcode, so you can interact with the Windows API, so you can basically do everything which you like. So in this case, what I'm doing, just say start PowerShell, and then I'm giving here the complete script inside, so it's encoded, and give here the base64 encoded script, and it will just be executed. So for example, I can also pass PS1 files, but PS1 files are not enabled by default, and they're also protected by whitelisting. So in this case, I just have to pass everything in the arguments. And what kind of script do we want to execute? So we can just have a look at PowerSploit, which is a collection of very cool scripts for PowerShell. And we see here something like reflected PLL injection, we can invoke shellcode, we can even start Mimikatz, stuff like that. So we can basically do everything which we like. And you see here, at this step, we already have bypassed application whitelisting, because we can just say start PowerShell, allocate space, and just load the PE file into the space, then make the relocation and imports and so on, and then you can just execute the application inside the PowerShell process. So we can basically already bypass application whitelisting. Here's another example of the script which I was using. This is from the social engineering toolkit. It just basically shows you how to import the different functions like virtual log or create thread. Then you just copy with memset your shellcode to the location and then just execute it. So quick recap, if we somehow manage to start PowerShell, we can bypass application whitelisting because we can start any application library which we like. But the big question is now, how do we start PowerShell? Because we cannot put it into a BAT file, because BAT files are also protected. And to solve this, my solution was to divide this overall goal of bypassing application whitelisting in several smaller steps. So I think this is always a good idea. Also, if you're exploit developing, just divide everything into smaller steps and solve everything on its own. And the first step for me is to get something which I call basic code execution. So I want to start some kind of scripts. And with the scripts, I'm then starting in the second step local applications and force these local applications to execute the code which I like. So an example for the second stage is then PowerShell. So first step is get something which I like JavaScript code execution. With JavaScript, I then start PowerShell, and PowerShell can then start my own shellcode. So I'm now running meshing code. The third step is optional, so I can disable application whitelisting, because during audits, it's just more simple if application whitelisting is then disabled. But you don't really need this step. You can just make step 1, step 2 again and again. And you also need often administrative privileges for this third step. I will now show you different techniques to get these different kinds of steps. So basic code execution, the very, very first simple ideas are, if I'm just sitting in front of the system, I can just type there PowerShell. So if I'm attacking kiosk systems or social engineering audits, so I have physical access to this machine, I can just type PowerShell. I can use the same idea with malicious USB sticks for social engineering attacks. So for example, for everyone who does not know this is Rubber Ducky. This is a USB stick, which is in reality a keyboard. So as soon as you plug it into your computer, it says I'm a keyboard, and then starts to type the stuff which you have configured. And I can configure here to type PowerShell with the payload. But the very, very typical attack, social engineering attack, is that I send my victim a file, he clicks on that file, and then it's just infected. And I wanted that this also works here, but the problem is that they really check many different kinds of extensions like exe files, MSI files, and so on. But what they're doing here is they're using a kind of blacklist approach, and every time you use a blacklist approach, you just forgot something. And in this case, they have, for example, just forgotten HDR files. So who of you knows HDR files? These are HTML applications. So it's a typical HTML file, but you can just use here VB script, and with VB script you can just get the COM object for vscript, and then you can, with this you can execute local applications. So in this case I'm just starting calculator, but we can also start, for example, PowerShell or some other kind of application. The same is true for JavaScript files, so I'm just sending a JavaScript file. If you click on it in the local context, I can again start any application which I like. Another idea is that I'm using file shortcuts. This maybe sounds a little bit ridiculous, but let's say I have compromised your intranet. Then you have a share on your intranet, and I just place a file shortcut there. Your administrative workstations are protected with application whitelisting, and if someone clicks on this shortcut, it's just infected because the shortcut is pointing to, for example, PowerShell again. I have especially included this one here because later I will show you how you can harden the system, for example, against the HDR or GS files, but you cannot harden it against these file shortcuts. So this was the main reason why I've included it here. But we can build on this idea, so it would look like this. But we can build on this idea, for example, with help files. This is a very old attack vector. You see the help file here. And inside this help file, I have included a button. The button is linking to a shortcut. And the shortcut points to the PowerShell. And then I just say in JavaScript, automatically click on this button. So that means as soon as you open my help file, you again start PowerShell and get code execution. And of course, there are many, many more such extensions, like here, encoded JavaScript files, and many, many more. So you always will find some kind of extension which you can abuse this way. Gadget is not so good because here you get some ugly warning, but yeah, there are many, many more. My idea was to look at the most common attack vectors which I'm using to compromise the system, and if application whitelisting will protect against this. So the first one was it's only social engineering. Another idea is that you're attacking a web application, and that means if you find some web application vulnerabilities, like if you can upload a shell or have local command execution, stuff like that, you can basically apply the same technique again, just start PowerShell with this. Another attack vector is pass the hash attacks. Who here knows what a pass the hash attack is? Okay. It's a little bit older attack vector, but it's a very good demonstration how simple it is to bypass application whitelisting. And that was the reason why I've included it here. So for everyone who does not know, if you have two servers and both servers have configured, for example, the same password for the local administrator, and you compromise one of these systems, you can dump the hash of this administrator and use this hash to authenticate on the next system. So you don't have to know the cleartext password. It's enough if you know the hash to authenticate on the next system. This is called pass the hash attack. And you typically then just go to all systems until you find the token or the cleartext password in memory of one of the domain administrators. Then you can attack the domain controller and you have compromised the complete domain. And you see here how this works. So for example, if I have a shell on one system, I can dump here the password hash, and then I use this same hash to authenticate on the next system, and then I just get a shell on the next system. And the problem is, if you have application whitelisting enabled on the target system, this is not working. And to find out why this is not working, you just have to look at the source code. So for example, in Metasploit, this is the main file. To implement this kind of attack, and you would end up calling this code here, this command here. So the next slide, it's a little bit more better to read. So for example, if I want to execute the whoami command on the target machine, I would end up calling this command. So what I'm saying is start cmd with a command. Then it says echo whoami, pipe to random name, so this thing here, into temp.bat, and then start cmd again, cmd start cmd again, and then start temp.bat. So basically start temp.bat, in which we stored whoami, pipe to random name. So our command, and pipe the thing to some random name that we can read the output. It's just so complex because they wanted to bypass some kind of antivirus products with this approach here to start cmd, which starts cmd, and so on. But you see here the problem is temp.bat would not be in the whitelist. That means the attack is prevented because you cannot start temp.bat. And it's really trivial to change this code. You just say cmd exit directly starts your command. and then you don't have to drop a local file, and then it also works against application whitelisting. So it's a very good example because you just have to modify one line of code and it's working again. So application whitelisting will protect you from mass attacks. So most attacks are really protected, but if it's a target attack, you just have to really modify very little things to make it work again. Next step is to get full code execution. So in all examples, I just use PowerShell. So an administrator can just say, I just remove PowerShell from my whitelist, and then I'm safe. And the problem is that there are many, many more such applications which can be used the same way. So for example, if you have script interpreters like Python or Perl, they're basically the same as PowerShell because you can just start anything which you like by passing the arguments to them. Or the same is true for debuggers. If a debugger is on a whitelist, the debugger can write to the process space of a whitelist application, so it can be used to inject your shellcode. And there are many, many more. So for example, some other very common attack vectors are Java applets. So what we are doing during social engineering projects is that we make a fake domain, which sounds like the real domain. Then we're sending emails, for example, to employees and say you can calculate your Xmas bonus on the intranet website. The intranet website points to our domain. And then we have there the Java applet, which says here you can calculate your Xmas bonus. So this was always working very good. Guys were always clicking on it. And the typical Java dropper looks like this. You have just the malware and the resources, then you write the malware to the temp directory, and then you just start it. And here again, this attack is prevented because the malware is not in the whitelist. But you can trivially modify it. You can just say start PowerShell instead, and then it's working again. But in this case, we wanted to do it without PowerShell. So what you can also do is you can directly inject your shellcode into the Java process. You can do this with the unsafe attribute. Unfortunately, I don't have enough time today to talk about this, but you can just have a look at this talk here. You can find it on YouTube, where the guy is explaining how this stuff is working. And the same also applies to Office macros. So the basic attacks are really prevented. So for example, we had a customer who had AppLocker installed and they had a choice dropper, and the choice dropper was really prevented because it's dropping a file. But you can really modify it, for example, with this script here, shellcode to Visual Basic script, and then you can execute everything in memory in the process of, in the Office process. And then it's working again. And of course, we have here some other attacks from other researchers. So for example, he was mainly targeting .NET framework, which is there since Windows 7. That means all these applications here are whitelisted by default. And what you can say is start install-util, and install-util will load your attack.exe file into its own process space and execute it there. So even if attack.exe is not in the whitelist, it can be executed because it's running inside the install-util process. And this is also a very good tactic to bypass, for example, endpoint protection systems, antivirus solutions, and so on, because they will all just scan install-util and not scan attack.exe. And basically, the others are the same. And if you really target a system environment which is really hardened, and every application from here is just removed from the whitelist, you always have the possibility to exploit some local applications. So because I just start the whitelisted application, and then I'm abusing some memory corruption exploitations like buffer overflow, format string, or use of the free bug, type confusion bug, and so on. So I can inject my own code into this process. So we have here two different possibilities. The first one is getting basic code execution, like I'm exploiting Adobe Reader or Chrome or something like that, so I think you already know this. But in this special case, we have a second possibility, which means if we can already execute HDR files or something like that, so we can start local application, we can target local applications, which has some advantages. So first of all, local applications, if you find a buffer overflow in it, they are very seldomly fixed because attacker typically has no advantage by exploiting this application, because you don't have privilege escalation there. So you will find many such local buffer overflows. It's very trivial to find something like that. And of course, we can also brute force there, install shims and so on. And the question is now, what kind of application, local application, we want to exploit? So we have two different possibilities. First of all, we can attack something from the operating system, or we can attack something which is there from McAfee application control. The problem with the stuff from the operating system is that the guys who develop operating systems really know what they're doing, at least the most time. So they know address-based normalization, data execution prevention, all the kind of protections. So it really becomes very hard to exploit such an application. And another problem is if I, for example, on Windows 7, other applications are stored then on Windows XP, then on Windows 10, then on some server variations. So that means I have to write one exploit for XP, one for Windows 7, one for English version, one for German version, one for ServicePack 1, ServicePack 2, and so on, which means it's really hard. And the good thing, if I'm attacking something from a McAfee application control, is that I will have the same binary on all systems, and of course, they maybe just forgot some of the protections to enable. In this special case, we have a third option because what McAfee is doing is they have this concept of trusted certificates. So everything signed by one of these certificates here, by this default list of certificates, can just be executed on their system. So it's basically a backdoor for them so that their own applications can run on application whitelisting enabled systems. So what we can do is we can just search for any application here signed by McAfee with a vulnerability in it. If you have this vulnerability, we can drop it on your system because it's then whitelisted, and we can just use it to get code execution. So what I was doing then was I just checked the program folder from McAfee application control. Then I found here the zip application. This one is from 1999. That means there are no security protections at all. And yeah, you can make a Google search. You will soon find here this execute code overflow with a score of 10, which looks very good. But there are no more public information, so they're not saying it's there, the vulnerability, or it's a buffer overflow or something like that. But we had the source code available. So you see here the source code. Maybe I'll give you here a short minute to have a look at this code. Just a quick hint, it's somewhere inside this box here. It's below here, the vulnerability. When I was doing this kind of research, I had access to a very expensive source code and static source code analysis tool because we had some trainings with them. And I thought, yeah, okay, I just run this tool against this source code here and see what this tool is reporting to me. And it reported me about 200 different buffer overflows. But the problem was that everything was a false positive because the guy was always saying first allocate enough space and then making a string copy of exactly this space. So it wasn't really no buffer overflow there, but just one buffer overflow. And exactly this buffer overflow was not found by this tool. And I don't really know why it was not found because it's really trivial. So you see here, this is the buffer overflow here. AirBuff has a fixed size, and we're just concatenating a space to it, and then the arguments are user controlled, so you can just give as much as you like there, and you can basically overflow the AirBuff variable. And I really don't know why this was not found by this tool. We also gave it to the trainers and to the developers, and they were also wondering why it is not found, but yeah, kind of strange. Yeah, so if you just pass many A's, the application just crashes. Then we can have a look at in WinDebug or some other kind of debugger. You see here it's exploitable. You can also have a look. We have control over this register here. You can then further analyze it down. We can control the arguments to these two codes here, and it's basically overflow in the BSS section, and we don't have no security features at all enabled because it's compiled 1999. So yeah, but there are some memory corruption protections, so we should not be able to exploit it. So here are some sites from them. MP stands for memory protection. You see here on Windows XP, memory protections are enabled, and we have something which they call CASP and something which they call Wasser. Wasser is disabled on Windows XP, but on Windows 7 everything is enabled, and we have something which is called forced relocation. And on Windows 8.1, everything disappeared, so there are no memory protections on 8.1. So my idea then was to just start some exploits, which I developed, look why it's not working, and then to find out why it's not working, and then work on it until it is working again. So I was just starting here a Firefox exploit, which I wrote. You see here, I'm using Windows 7 because on Windows 7 we have all protections. Everything is enabled. I'm not just starting Firefox. This is now my exploit. If I hit the go button, the exploit starts to run, and in this case, it just worked without any modification. So, okay. So my next step was what to test else. So my idea was, okay, this was an integer overflow, and they just say they protect against buffer overflows. So the next step was to test the stack-based buffer overflow. So for C player, I think I just skipped this demo because it's just working again. So no modification, everything was working. I tested it with, I think, 20 other applications, and everything was just working. And I was wondering what the fuck is ongoing. Yeah. So the next step was to use a debugger to look at the stuff, what is ongoing there. So basically what they're doing is they're injecting this library, sc inject DLL, into all applications protected by them. And then you end up getting many, many different kinds of exceptions in the debugger if it's protected, and it's always around this address here. So the next step was to find out what is stored at this address. So if McAfee application control is not there, you find there the PE header of kernel 32, and this PE header is typically readable. And what they are doing is they just remove the readability, so it's not readable anymore. That means as soon as someone tries to read this PE header, you get an exception. And then their own exception handler can kick in and add additional protections. They're doing this kind of stuff because shellcode typically reads this PE header, and as soon as you read it, you get the exception, then the code can kick in and can check if shellcode is currently executed or not. And what they are doing is they just check is the current instruction, the triggering instruction, belonging to an executable page. So what they are doing is they just implement the data execution prevention, which is there from the operating system per hardware, in software. So it's only really useful on very, very old hardware. And this is also the reason why my stuff is working, because my exploits are just developed to work on the most recent operating systems. That means I already have to bypass data execution prevention. That means I bypass their protection as well at the same time, because my code is marked as executable. Another interesting thing is that they allocate in every protected application a section here, which is writable and executable, which is just stupid, because it just breaks the idea of data execution prevention. So what you don't want is a section which is writable and executable, because an attacker can then just write his own shellcode to this location and directly execute it. So the idea of data execution prevention is that you don't have such a section, and by implementing this kind of protection, they just break it, the one from the operating system, which is kind of strange. Yeah, I have then included here some shellcode which can be used to bypass their protection. And so basically CASP is the same as the data execution prevention from the operating system. Wasser is the same as the protection address-based reorganization from the operating system, and forced relocation is the same as forced ASLR. So they basically have the same protections as the operating system, just for some old hardware that is also working there. The next thing is user account control. So all techniques which are presented to you are working as normal user. But now the following techniques, for example, how you can disable application whitelisting, requires you to be administrator. And for that, you have to bypass user account control if the target user is an administrator. I think every one of you knows this, user account control. It was introduced with Windows Vista. These are these little boxes. That means if you log in as an administrator, you now receive two different tokens. One token as normal user, one token with full admin privileges. If you want to use this full admin token, you have to click here on yes. And I unfortunately don't have enough time today to talk about all details here, but there are many, many different public techniques how you can bypass user account control in the default configuration. And this mainly works by injecting code into so-called auto-elevated executables. So the problem with Windows Vista was that you got very, very many such dialogues. And with Windows 7, they introduced auto-elevated processes, which means Windows science stuff don't have to show you this dialogue. So for example, if you open Notepad and go with a Notepad file open and go to System32, you can create their stuff without triggering this dialog here. And this is done with the auto-elevated applications. In reality, it's a little bit more complex, but I don't have enough time today. And these main techniques here work by injecting code into one of these auto-elevated processes by dropping a DLL there. That means if you start, for example, sysprep, which is auto-elevated, you force it to load your own library. And the problem is, if you drop the library there, the library is not in the whitelist. That means this kind of bypass is not working on if application whitelisting is there. And there are some other techniques. For example, you can use this WUSA application to drop it there and so on. But they're just not working. And what the main message is just there are some techniques which are working. For example, what you can say, someone of you knows Shims, the Microsoft Windows Application Compatibility Toolkit. You can install them. So for example, what you can say is, I redirect the exe. So for example, if you start the auto-elevated executable, you can say redirect it to my own malware. So my malware is instead executed, but the manifest file is taken from the real file, which means my file is now auto-elevated. Some kind of that techniques. But the problem with this technique is that it's only working on very old systems. So for example, on 32-bit systems. We can also say here with some other techniques to make the registry writable to disable user account control. But in this case, you have to reboot your system and it's not working on Windows 10. But we also found some private ones. So for example, what we're doing is, for our social engineering projects, we need some private techniques which also come around the antivirus products. And these techniques also work if application whitelisting is there. So you can bypass it if you like. As already mentioned, there are some processes with some special privileges. These can be used to bypass the protections like read and write protections. So this is mainly the update processes because they can overwrite write protected stuff. And we also have the service. The service is kind of cool because we can, first of all, read everything which is read protected, and we can remove, for example, the password file. So what we can do is, as soon as we run inside the service, we can remove the password file and then just say sadmin disable to disable all protections. But injecting code into this service here requires you to be administrator. So you can attack the updaters if you're a normal user, but for this technique here, you just have to be administrator. But it's not really required, it just makes your life more simple. Here again, the update processes. What you see here is test.exe is whitelisted, so I cannot overwrite it because it's write protected at the same time. So if I want to copy test.2 over it, you say here access is denied, and the content of it is old. Then I can just run my own update process, which overwrites it, which works fine, and then I see it's just overwritten. And the basic idea is that you just inject your own code into one of the update processes. So for example, the Java update process here is whitelisted by default, also is an update process by default. So what I'm doing here is I have my bat script, and then I'm just injecting my code into this Java update process, overwriting it there, and I have here my new content. And the problem is that they are just identifying this update process here by the name. So even if it would run as with higher privileges, I can just start it as normal user and then inject my own code into it. So yeah. As already mentioned, we can also inject into the service if we are administrator, but that means we have to bypass user account control, or we have to find some kind of privilege escalation exploit if you're not an administrative user. But then we can just remove this password hash file, or we can, for example, add a trusted volume, which means it just disables the protections, but you don't have to reboot your system in this case. And we also have here some kernel land related vulnerabilities, which just I think I'm very sure it will allow you to escalate your privileges. For example, if you're a normal user, to get administrative or system privileges. I have now some demonstrations which show you the techniques. So this is so I'm starting it as administrator, and here I'm just saying so first of all, everything is disabled. Then I just say scan the system for all files. So I say solidify. So it's now iterating over all files. Just go to the next demo. Now it generated the whitelist here. So the next thing is that I have to say to enable all the kind of protections. So it's still disabled. Now I'm saying enable. I have to reboot my system. Now logging in as a normal user, so user in this case is an administrative user, normal user has no administrative privileges, because I want to show you that everything is really working as normal user. You don't have to be administrator for all the techniques. You see here, if I try to start it, it just says you have to be administrator, so you cannot do it. Just see, I'm no administrator in this case. Just skipping this part here. Yeah. What I'm now doing is I create here a bat file. I write some content into it so that you show that protection is really working. So if I now want to start this new bat file, this bat file is not in the whitelist, so you cannot execute it. The same applies for executables and so on. So the next step is to bypass the protection. I have here one whitelisted file, so you just see here a dialog. If I copy this file, the new one is not in the whitelist, so you cannot execute it. You get this access violation, access is not denied message. You can remove this because it's not in the whitelist. That means it's not white protected, but you cannot remove the whitelisted one. So it just says first, you don't have enough privileges. Try it as administrator. So I'm not trying as administrator. And it says you can still not remove it because it's write protected from the kernel end. So I'm now on the tech machine. My idea was to show you that it's really simple to bypass this kind of protections. So I just use public available tools. So in this case, I'm just using social engineering toolkit together with MetaParameter session. But you can also implement all that kind of stuff in shellcode yourself. So what I'm doing here is I just say, create me this PowerShell payload for MetaParameter session, giving here the reverse shell IP. So you find here the payload. So it's basically the payload together with the complete script. And I'm now on the victim machine. I created this virus file, which looks like a normal application, but it's a HDR file. And you can just open it in Notepad. Can everyone read it, or is this so small? Maybe. Yeah. So basically, it's an HTML file, and you just say there, start PowerShell, and then immediately close the window again. You can also start some other kind of application then, for example, to fake that it's a game or something like that to trick a user. And yeah, on the next slide, you just see here. If you click on it, it was now executed, but you can also start some applications to fake it, to trick the user, and you just get here the session. You can then have a look in which process you're running. So in this case, I'm running inside the PowerShell process. So I'm on the desktop. Next thing was I tried to upload putty because putty is my fake malware which I want to execute, but putty is not in the whitelist. Right, here are some problems with the syntax. So I've now uploaded putty to the desktop, and the problem is putty is not in the whitelist, so I cannot execute it. So if I try, I just get an access is denied. The next step is I have here the whitelisted exe file. The next step is that I want to overwrite the whitelisted file with my putty.exe, with my malware. So I'm trying to overwrite it, but because it's write protected, I cannot overwrite it. Access is denied. So the next thing which I'm doing is have a look here at the running processes, and you find here that the Java update process is running. It's done here. So the next thing is that I just migrate from the PowerShell process to the Java update process. So I'm just injecting myself into this process. And because this process has this special privileges to override white-protected files, I can then now overwrite this whitelisted file. So I'm now inside this Java update process. Now going to the desktop again. So in this case, you see, you have now overridden it. And you see here in the graphical user interface, you cannot execute putty because it's not in the whitelist, but now you can execute the whitelisted file, which is putty, which should be your malware. And I have here one final demo, but I just skip here the stuff. In this case, I'm just an administrator, and you see here, if I want to execute some kind of commands, you have to provide the password, but I don't, as a attacker, don't know that password. So what I can do is, if I'm administrator, you can remove this password file. So if I'm inside the normal process, I cannot read this password file because it's read protected, but I'm now injecting myself into the running service. Just go here a bit. So I'm now inside this service. And this is the only technique which really requires you to be administrator. Then I can read this password hash file, and I also can remove it, which means as soon as it is removed, you can just say sadmin and then, for example, disable or add trusted volume to disable all the protections. So in this case, you see I don't need the password anymore. Yeah. Conclusion. So in my opinion, application whitelisting is a really good concept because it helps you to protect against mass attacks. But if someone tries to target your company, it's really trivial to bypass. And in some cases, it can even lower the security of operating systems, for example, if they allocate writable and executable sections, or if they have kernel-end vulnerabilities. Here are some hardening guidelines. Basically, just apply updates and remove everything from the talk, so all the applications which can be abused, and so on. Just have a look at the advisory where you can find more such hardening guidelines. Here's the response from the vendor. So what they were saying is, for example, that we allocate something which is writable and executable. Okay, it's very, very complex to exploit such stuff, so the risk is very low. Also that they installed something from 1999. It's very hard to exploit this because we have buffer overflow mitigations and so on. So risk is also very low. And to all the other stuff, they just said they are theoretical and there is no proof of concept, which is kind of strange because I sent them all this kind of stuff and techniques and code and so on. But yeah. Another very strange thing is that they told me you have to be administrator to inject something into the update process, which is just wrong, because the update processes are just identified by the name, and you can just start the update process with your own privileges as normal user. So, and also the demonstration showed you that everything is working as normal user, so you don't have to be administrator, only if you want to inject into the service. And the same is true for the kernel-end vulnerabilities. They told me that you need to be administrator, which is just wrong, because you can't do the stuff as normal user. And of course, you have to run untrusted binaries, and that is not possible on their systems, and so on. Yeah. Then they just told me, okay, everything is classified as low, so we will not fix it in your disclosure timeline. And I think this was the last thing which I heard from them. So we also wrote them, we should really fix that stuff. But yeah. Also very interesting fact is we then released, I think 60 days later, our advisory. They didn't fix anything. And I think 3 months later, someone from the Zero-Day Initiative, maybe they come across our advisory, just found the same kernel-end vulnerabilities in them and just reported them to them again. But yeah, however. The current version which you can download on the website is this one here. But if you have credentials and can log in there, I think there's also a version 7.0, so maybe it is fixed there. So on the version which you can download on the website, all is still there. But I don't know if they have some kind of hot fixes there, and they also don't reply anymore to me. But yeah, one of our customers, I think they have 7.0 and will have soon the possibility to test it there. So maybe they have fixed something there. Maybe I will find more there. But, yeah. Yeah. Thank you very much for your attention.